So today we're going to be making this bracket. It's for a bed cover for a 2025 Chevy Colorado, my dad's truck. His bed cover that he bought, I don't remember the brand. I'll have to... What? Is it a GMC? Oh, wait.
You said Chevy.
Yeah, I said Chevy Colorado. It's a GMC Colorado? No, GMC.
Wait.
What's that called? What's the
Canyon?
Canyon. Yeah. Far, far away. Anyways, this doesn't come down far enough. The actual little stud that comes out that goes and goes underneath, it hangs about 1/4 inch away from this, so you can pull the bed cover up and down. That leaves room for someone to be able to stick their hand in there, pull the bed cover up, stick a thing in there, and pull it open, steal shit. You don't want that happening. And these will be for sale as well once they're done. I've got a couple ideas for how I'm going to go about this. Idea 1, remake the whole thing. Get it made through Cut Send, CNC, or if they do cast. I don't know if they do cast. This is cast, I can tell. But might have it CNC, billet bed cover clamp. It's going to cost way too much than it's worth. So the other option is I can 3D print a little piece that goes through here, clamps in here. There's a bolt that holds it together, and then it extends this down 1/4 inch. That's the simpler way to do it. That's how I'm going to do it, to be honest with you, for the time being until I figure out the other way. But I'm going to show you the CAD for figuring out how to reverse engineer this part itself, and those files will be available on Colts 3D, Thingiverse, wherever you want to go. You can also find them on my Facebook, probably. You can find the links to them on my Facebook, and I'll put the links to them on this video as well. But you can also find our TikTok, and that'll have a really quick video, short form, if you don't want to watch the whole video of this, which I can't imagine this is more than like. So, stick around, pay attention, you might learn something. I'll probably learn something too. Anyways. So first things first is we're going to need to get a reference for what this shape actually is. There's a couple ways you could go about designing it in CAD. I could open up my CAD and I could take my various measuring devices and I could sit here and go, all right, this is 234 thousandths. And this little piece on the inside, this little hole, it's about 104,000. I can sit there and do that. I could do that all day. There's a better way. So we're going to use a 2D printer. Write that down. A 2D printer. Paper printer. Epson. It's got a scanner. It works. You're going to take this part. You're going to take a steel rule, or you could just use a ruler. It doesn't have to be steel. You're going to take a ruler. It's a reference for your measurement. You're going to set these down on the printer. Yes, however orientation you want. We don't judge here. But I'm going to set them as straight as I possibly can, just so that when I transfer that scan over to CAD, it's straight enough that I can put it in CAD and not have to fiddle with it too much. When you import this image into CAD, you're going to be able to go into the settings, not the settings, but the settings. My video cut off because I forgot how my gimbal works. When you go into CAD, and I'm going to show you that, there will be a specific place that you can go to within that canvas. We are specifically on Fusion 360. I've never operated SolidWorks. I started doing CAD on Tinkercad. That's a free browser-based one by Autodesk as well. So I went from still on Autodesk. I love Fusion. I used to do Blender, and I can put some pictures of that up here. As far as I got on Blender, I just did the donut tutorial, and people who do Blender will probably know what I'm talking about. It's like an 18-hour tutorial. I think I did it when I was like 12. It took a long time. I didn't like Blender. And the whole reason I started doing CGI like Blender, stuff like that, was because I watched a YouTube channel called Corridor Digital. Cool as fuck. Just check them out. Anyways, we're talking about engineering. This will give you your basic shape, and you will have to do infinitely less work. I don't have to sit there and start, like, if I were to design this without that, okay, we're going to start at one corner and we're going to work our way all the way around. So first I would start that and I would go, first I have a line, just if you wanted me to break it down. First I have a line here. I'm going to start that right here. I'm going 90 degrees straight for however 150 thousandths that direction. Okay, then I measure the distance from the top of that to the bottom of that. That's probably about 250 thousandths because you would get 50 thousandths on either side for the width of each little nub. And then, okay, now I'm going to go 350 thousandths to the right. And then I go up, I step up to a larger thickness for this thread. And I go off in this angle, this, all that. And that's where you start to lose me, is the angles. You can do it. You can totally do it. There are people that do it all day, every day. But when you have access to resources like this where you can just throw it on a printer, scan it, and be done relatively, why not save the time? So we're going to transfer to CAD real quick, and I'm going to show you how to do that. Okay, so over here on CAD, first thing that we're going to do is we're going to go up to here, Canvas, insert from my computer, blah, blah, blah. We got this. We got to pick a plane, pick the bottom plane. We don't do any scaling right now, okay? Just leave it how it is. You can rotate it and kind of get it lined up with the grid. And I think earlier I had it at 88 degrees. You can kind of go off of, scoot it down, below that line a little bit. You can go to rotate. Okay. So, -1, that's a little bit better, -1.5. Perfect. So get that lined up. So next thing that you're going to do, see the ruler in there? It gives you your reference. Come over to the timeline over in the right. That's your browser, not your timeline. Timeline's at the bottom, sorry. You're going to go to calibrate. You're going to come down to your ruler. So we'll just do 2 inch to 1 inch just to make sure it's more accurate so we didn't lose anything off the edge of the ruler. In this case, my ruler is brand new. I have it in here for that specific reason. And I know it's not going to be worn down, but some rulers that have been in the shop or anything like that, they can wear down over time on the edge, especially if they're being put up against like CNC machines, stuff like that. So there we go. There's our general shape. So now that our image is imported and calibrated, we can actually get to the design work. So I'm going to start a sketch on top of this plane. And this is the easy part. You're straight up just going to start zooming in, drawing the design. Don't worry about drawing all the fillets. Draw the basic, rough, square shape. And I mean that. It's going to make your life infinitely easier. You're going to make everything more uniform if you start off with just the rough, square shape. If you went in here and just started drawing all the fillets right now, it would get super confusing. You'd get lost in all the different fillets and all that. And to be quite honest with you, just from experience, I've realized that it's a lot easier to add the fillets later. I'm by no means a professional. Also, I don't have any degrees. I would like to work on getting them, and I am, but this is just some information from someone who has learned over time and just kind of figured things out on my own. So take everything you hear from me with a grain of salt, but I'm trying to do my part to help people out, because when I tried to learn this stuff, it was before we had Bamboo Lab printers, and it was kind of just trial by fire. And I mean, there were tutorials out there for this. There was definitely a bunch of tutorials, but some of them are kind of hard to understand. And my goal with all of this is to try and help people understand a little bit more. This kind of work can be pretty daunting. I've talked to some people who've wanted to learn, and I've got some guys that I work with on a daily, weekly basis that I work pretty closely with, and they want to learn. But thankfully they've got me right there and I can teach, and I love teaching. But at the same time, I kind of want to spread the knowledge a little bit more farther than just the people that are around me. So let me get this designed. I will be back with you. So another benefit to doing something like this with the scanner is we can get a better kind of rough estimate of what our fillets are at. Now that we have this image in here, we can see, okay, that's the contour that this is following. So we can grab this edge and drag the fillet out until it loosely matches that fillet. And we can add another over here, and it gives us our shape a little bit more. That's just another benefit of using this to get your basic shape down. Way less work. Busting out a radius gauge for something this tiny would be crazy. I'm sure they exist, but anytime I can avoid something like that, I will. And don't get me wrong, maybe that's causing me to spend more time on certain things. Maybe because I don't do all of that, I'm losing some time having to prototype things multiple times. Maybe that's why I have some things that don't fit up perfect the first time. But you know, that's kind of just some of the things that I learn over time. And you know, down the line, when I make more of these videos, I will probably come clean on that, just like I'm coming clean now, and say, okay, sometimes it's worth it to bust out those gauges. In this particular instance, I don't think it really matters. If I was a little bit wrong on this radius right here, there's nothing fitment-wise that's going to mess with me. There's nothing on this side that's going to bother me. This bolt right here goes up into the rail going into the car. The main things that really matter is this area, which looks a little rough. So I can grab this point right here, scoot it over. That will do weird things sometimes, and that gets a little bit closer. So now the next thing that I'm going to do is I'm going to check some measurements. I'm going to measure from this piece to this piece down here. .234. So I'm going to grab this piece. That would be this right here. And measure this from here to here. Look at that. 0.234. So that kind of just shows you how accurate this method can be. But, you know, it never hurts to double check to make sure that our scan is actually translating to CAD properly. So we're going to finish this up. I'm going to extrude this up. We'll go up here, extrude, bring it up. And this is when we will take our measurement. This is one of the situations where you will have to measure. So we'll get our width, 0.721. Take that over here, 0.721. Boom. There we have it. That is our piece. The first couple of things that I'm going to do is I'm going to clean up the edges around here a little bit, probably add a little bit of a fillet on there. To be honest, it doesn't matter too much if I send this to a machine shop to have it machined, or if I see if I can get it casted. That stuff is going to be so minimal, I'll probably end up filing it off myself by hand. 3D printing wise, it'll probably show up a little bit, but 3D printers are always a little bit rougher than you might think. So, depends on your nozzle size. We're running a 0.6 millimeter hardened steel nozzle right now for use in carbon fiber parts. And you can see our carbon fiber parts on the channel if you want to. It is a intake for a Volkswagen Jetta GLI. It's one of the harder things that I've done all the way through, just reverse engineering, taking the scans, test fitting. We went through a couple prototypes on that, and it used a lot of material, but we've reached the last prototype, and we're working towards making a finished product that we can sell. But it was all worth it in the end. So, you'll notice I did not put a hole in this. I will probably still do that. Maybe. We'll find out. This little area right here, if we really wanted to machine that, that'd be a really small end mill. That's kind of dumb. So real quick, as you can see in the scan, we actually do have a bolt in this that will thread through. So here's our bolt. Tiny little Allen head. This is what actually goes up, goes through that bracket, and then the bed rail would be right here, and it pushes up against that, which clamps it down. So this is what holds it in place. In order to get your bolt size and like your teeth for your CAD, you need a TPI gauge. Actually, you don't need this. You could, if you're measuring teeth per inch, you could just make your calipers 1 inch and count the teeth, and then you could probably get a pretty good estimate of that. Me personally, I like to use TPI gauges. This gives me a pretty accurate guide. You can get these on Amazon for really cheap. I bought this one off Amazon. You can see, fits into those teeth, give it a wiggle. It doesn't move, boom, that's your TPI. So we are at 1 inch. Oh, that's millimeter, isn't it? But another thing we're gonna have to add is the hole. So I'm gonna be so honest with you. This is where I would take one of those liberties and say they probably put that hole at center. It doesn't really look completely centered. So I can measure, this is what I'll do. Measure the width, or the diameter of the hole. So it's about 203 thousandths. I'll measure to this edge. So 250 thousandths, so it's a 1/4 inch to the edge. So it's probably at about 350 thousandths to the center of the circle on that side. And probably, yeah, it's not center on this piece, but to be honest, that could just be where they cut it off. I'm going to put it at center on my piece because I know it's not going to matter, and I don't think there's any specific reason for that. We're going to find out. You know what? I might put it on the truck and be like, oh, should have put that 30 thousandths slightly to this direction. But in this case, I think it's okay. So for the hole on the side, I measured the bolt. It was 0.227 thousandths, so 227 thousandths. We are now going to finish that sketch. Come back here, hit an extrude. You can also hit a hole. Put a hole on there too. I just like to do extrude. Now we can do create. What the hell? There they are. I was like, what? And then we can do, it was 5.77 millimeters, which is weird. We're switching thingies. We're going to do 6 millimeters, and it was by 1. And I'm going to put these threads as model just so that I can see them. Boom, that's it. So there's our piece. Now we've got our new piece made. It comes down an extra 1/4 inch just to make sure it's properly locking. We're going to test print some prototypes out of probably ABS and try them out just to make sure it's locking. And then we'll figure out how to make it out of metal after that. We may cast if I can figure it out. Or if Send we'll machine it. We'll see how much that costs and maybe get it machined. If I can get away with 3D printing it, I would. But if I 3D print it, it's likely going to have to be a section that clips onto this, which I might do off camera. And just, if this video does well, I will make another video on that. Teaching how to incorporate like bolts and nuts into it to fasten them together. And I think this is pretty common knowledge, like using bolts and nuts and stuff, but you know, you can learn a million things from someone and only pick up on a few. And you could have another person explain 2 of those things to you differently. And you immediately take up 2 of those things just because the way that they explain it is better. Hopefully I explain things decently. I'm pretty monotone when I'm explaining stuff like this, but it's because I lock in and then I stem out and then I'm like, so basically you do it this way and this way and this way. And so it's late. It's like midnight. We're trying to do research on a Porsche 944 because Bryson wants one. If we do buy that 944, I told him we have to take it to Pikes Peak. I don't know if we will. We'll see. But anyways, 3D printed bodywork coming your way. Yeah. This video better do well. I want to do that shit. I'm gonna do it anyways, but I would like to show people that they can do it too. And I'm gonna teach all the processes that I figure out on my own or find out on YouTube. If they're on YouTube already, I'll explain how I do it anyways. But anyways, thank you for watching. I'm gonna circle back and show a finished piece, or I might show the finished piece on TikTok or Facebook. But if you're interested in more stuff like this, share it with your friends. If your friends like CAD, it's kind of a nerdy thing to share, but I share it with my friends. So
He's a nerd.
Yeah, I'm a nerd. You can make money off this shit, so I think you should share it with your friends. Tell your friends to get off their ass and start stacking dimes. I can't even say that. I don't make a whole lot of money. Anyways, thanks for watching. I hope you learned something. And always, yeah, don't talk to strangers. Yeah, stranger danger, y'all. Stay safe out there. Don't dial like a hurricane or something. That would suck. That would also suck. Don't waterlock your car.
Hey.
Subarus are really bad, especially.
Hey, who knows? Maybe it was a blessing in disguise.
Blessing in disguise. Yeah, if you get a 944, that would be a blessing in disguise. Need more chicken.